my dear students, I hope you all are doing great. Once again, I welcome you to my channel. Take it seriously. Today, I'm going to start a new chapter of class 10 CBSE. Yes, you heard me right, class 10th CBSE chapter number 5, Arithmetic Progression. Why I specifically chose this chapter? Because I think this chapter doesn't have any loop prior to 10th standard. And it's going to be a very fresh chapter to start with, so that's the reason I chose this. Okay, now this video is going to be a very basic introduction video in which we'll be discussing the basic definition of arithmetic progression AP and all the 4-5 formulas on which the whole chapter is based upon. Yes, literally 4-5 formulas and the whole chapter is done. So once you know these formulas, the whole chapter becomes a cakewalk for you and you can solve the questions in snaps of your fingers. Not this easy, but yes, it's definitely going to be easy, right? So let's start with the basic definition, okay? So my dear kids, let's understand arithmetic progression with an example, okay? So you all get pocket money, right? Some of you might be getting 200 rupees, 300 rupees. Some of you might be getting 2,000, 3,000, whatsoever. But that is something not of my concern here. Okay, so let's say you get a pocket money of, let's assume that 200 rupees, okay? And somehow this month, you managed to save 100 rupees, okay? You managed to save 100 rupees and that 100 rupees you thought of, saving in a piggy bank. You put that 100 rupees into a piggy bank, okay? So you saved 100 rupees this month. So this month you saved 100 rupees. But now you know that your expenses per month are, like, you won't be able to save 50 rupees every month, 100 rupees every month. So you decided to save 50 rupees thereon, okay? So you thought of deciding saving 50 rupees every month now on, okay? So next month you again put 50 rupees into your piggy bank. So this month you saved 100 rupees, okay? In your piggy bank you already had 100 rupees and now next month you're putting 50 into it. So what will be your saving by the end of next month? Your saving for the second month would be 100 plus 50, 150. Now for the third month, your saving would be 200. For fourth month, your saving would be 250 and so on. Okay, so your monthly savings, so you can see your monthly savings is forming a sequence, is forming a pattern. So here this sequence of numbers, you can see that the next term is obtained by adding a fixed number to the previous term. So this 150 is obtained by adding 50 to 100. Okay, so 200 is obtained by again adding 50 to 150 and again 50. So this type of sequence of numbers in which the next term is obtained by adding a fixed number to the previous term is known as arithmetic progression. Or you can say arithmetic progression is a sequence of numbers in which two consecutive terms differ by a constant number or a fixed number. Okay, I'll just write the definition somewhere on the screen. I'll just paste a snippet of it, so don't worry about that. So the gist is the difference of two consecutive terms is fixed, is a constant number, and that constant number is known as common difference of that AP. Common difference, okay? So common difference is denoted by small d. So this is common difference, and common difference of an AP, you can see in this case the common difference is plus 50, positive. But common difference can either be positive, it can also be negative or a zero. So common difference can either be positive, negative or zero. So I'll just give you example of these two cases as well. So let's take this example, this AP, okay? 4, 2 and so on. So here in this case you see the next term 8 is obtained by subtracting 10 from 2 from 10. Okay, so 10 minus 2 is 8. So here the common difference is minus 2, okay, because this next term is obtained by adding minus 2 to the previous term. So the common difference is this minus this, 8 minus 10 is minus 2. Common difference 6 minus 8 minus 2. So the common difference is minus 2 in this case, so negative, right? Now let's take this example, 4, 4, 4 and so on. So this is also an AP because the common difference here is 0. And as we know that common difference can either be positive, negative or 0. So this is also an AP, this one is an AP and this one is an AP, right? So D common difference can either be positive, it can be negative or a 0, okay? So that's a AP, right? Now let's talk about nth term of an AP, right? Now let's talk in general, right? So let's say there is an AP whose first term is A. The first term is A and the common difference is D, okay? So this is the first term and this is the common difference, right? So D is the common difference. Now, if A is the first term, D is the common difference, so first term A1, A suffix 1 means first term. And we assume that the first term of AP, we generally denote the first term of an AP by A. So A1 first term, and in this case the first term of an AP is A, right? Second term, how we can get the second term of this AP? Second term can be obtained by adding D common difference to the first term, right? So A plus D, okay? So here I am doing. So you add D to this term, A plus D, so you get your second term, okay? Now third term, how you can get third term? You will again add D to this second term and you will get the third term, right? So it will become A plus 2D, D plus D, 2D, right? Third term. Now just see this sequence, see this pattern. Second term, single D. Third term, 2D, right? Fourth term of this AP, you will again add D to the third term and you'll get fourth term. So A plus 2D plus D, it will become A plus 3D, okay? So are you observing this thing? Fourth term is 3D. 4 minus 1, 3D, okay? Fourth term, 3D. Third term, 2D. So if we follow this pattern, okay, this pattern will continue, right? So that's how the nth term would be, nth term of an AP, A suffix N, nth term of an AP would be, fourth term is 3D, so nth term would be A plus N minus 1D, N minus 1D. So this is the nth term of an AP. This is the formula for nth term of an AP, and this is also known as general term of an AP, okay? Why so? Why do we call it general term of an AP? Because you know, using this formula you can get any term of an AP for that matter, like any term, means first term, second term, third term. Just you need to put the values into this formula and you can get the specific term using this formula, and that's why this is known as general term of an AP, okay, right? So now let's talk about types of AP. So AP can be of two types, finite and infinite, as the name suggests. Finite means the number of terms in that AP would be finite, okay, means you can count the number of terms, how many terms the AP has. And infinite AP would be like infinite, counting the number of terms is next to impossible. You cannot count how many terms the AP has, okay? So it can have, the AP can be of two types, finite AP and infinite AP. So let's take some examples of both so that you understand it better. So finite AP, let's take, let's say I gave you 4 crates of oranges, right? And in each crate, you know, the number of oranges are in such a way, like in the first crate 40 oranges, second crate 55, third crate 60 and then 65, okay? So you see, in all these 4 crates of oranges, the number of oranges are like this, okay? So you see that they are forming an AP. The first term is 40 and the last term is 65. So this is a finite AP because here the number of terms are fixed. So this has 4 terms, right? We can count the number of terms. So it has 4 terms. So this AP has 4 terms. So that's why it is finite. We can count the number of terms. We have the first term, we have the last term, right? And last term of AP is denoted by L. L is last term of an AP. Last term, okay? Now, let's take an example of infinite AP. If I ask you, tell me the positive even numbers, all the positive even numbers. So let's start. Positive even numbers. So they start with 2, right? Then 4, then 6, then 8, then 10, and so on. The list is long. Okay, you don't know where it will end, right? So infinite, it extends infinitely, right? And the last term you don't know. Okay, so the first term you know, but the last term is not known. For such an AP where the last term is not known, these APs are known as infinite AP, because you cannot count the number of terms. How many terms are there? You cannot count, right? So this type of APs are known as infinite AP. Okay, let's now move ahead to discuss sum of n terms of an AP. Now let's try to find out the formula for n terms of an AP. Sn, sum of n terms of an AP. So S suffix n is sum of n terms of an AP. Okay, so let's derive this formula. Okay, now let's say there is an AP whose first term is A, second term is A plus D, third term is A plus 2D. This is a general AP, right? Fourth term, so on, and the nth term would be A plus n minus 1D. Okay, now let's say this is nth term would be this, and just the term prior to the nth term, just before the nth term. So if A plus n minus 1D is the last term, then the term prior to this term would be A plus n minus 2D. Okay, so A plus n minus 2D. Okay, so this is the second last term and this is the last term, right? So this is an AP, okay, in which the first term is there, second term, third term, so on, second last term and the last term, right? We need to derive a formula to find out the sum of these n terms of this AP. We need to find out Sn, okay? So Sn means sum of all these terms, means A plus second term, A plus 2D, A plus D plus A plus 2D, right? And so on. Then this term A plus n minus 2D, and then this term, last term, right? So this is A plus n minus 1 into D, okay, right? A plus n minus 1 into D. Now let's reverse this AP, okay? So Sn, let's write this sum this way: this plus this plus this plus this, okay, in a reverse order. Sum would be the same, right? You add 1 plus 2 plus 3, or you add 3 plus 2 plus 1. The answer would be same. So instead of adding it this way, we are reversing the order and we are adding it like this: A plus the last term n minus 1 into D, okay, the second last term plus this term A plus n minus 2D. Okay, this is the derivation of this formula is not important. This is only for those students, you know, like those knowledge hungry students. Okay, so only for those students. If you get it, you get it. If you don't get it, no worries. Just remember the formula that I'll be telling at the last of, you know, at the end of this derivation. Okay, so A plus n minus, this is the last term, second last term, and so on. And then this third term, A plus 2D. Then this term, second term, A plus D, and the first term is A. Okay, now let's add these two equations. So this is equation number 1, this is equation number 2. Now let's add these two. So Sn plus Sn will be 2Sn, twice Sn. Okay, now A plus this will add, okay, I'll just use a different pen so that you understand. I'll add this with this, first term, this term will be added to this term. Okay, now this term we'll just skip it because the answer would be same. Now this last term will add to this term, and this second last term will add to this second last term. Okay, the rest will follow the same sequence. Okay, now A plus this, so it will become A plus this would be A plus A would be 2A, right? So we'll get 2a plus n minus 1 d. Okay. Now a plus d plus this second term. So a plus d. Now here a plus a will become 2a, right? 2a and n minus 2d, okay, plus d. So here plus d and this you will add it. So I'll just write it here. So it will become this plus d means n minus 2 d plus d. So let's take out d common and we'll get n minus 2 plus 1. So n minus 2 plus 1 is n minus 1. So n minus 1 into d, right? So this plus this will become n minus 1 into d. Okay, and so on. This sequence will repeat, right? So just need to start, write the first two terms and then last two terms so that we get exact answer. And then the last two terms, okay, the second last term this with this and the last term with this and this. So this term will add to this term, right? These two terms, okay. So a plus a, again it will become 2a plus n minus 2d plus d. The same thing, we'll take out d common and inside the bracket will be left with n minus 2 plus 1 and n minus 2 plus 1 is n minus 1 into d. Okay, n minus, is this clear? I don't know. Minus 1. I just hope it is clear. Okay, now this is the second last term and for the last term it is a plus n minus 1 d plus a. So plus a, 2a plus a will become 2a plus n minus 1 d. So this is the last term, 2a plus n minus 1 into d. Do you see? All the terms that we have obtained, all the terms, they are 2a plus n minus 1 d, 2a plus n minus 1 d and so on. So how many terms were there initially? N terms, and we have added these two terms. So now in the final statement, this term will be repeated how many times? N times, because there were n terms. So 2 plus n minus 1 d, 2 plus n minus 1 d, we are adding this number 2 plus n minus 1 d, 2 plus n minus 1 d, 2 plus n minus 1 d, 2 plus n minus 1 d n times. Okay, if you add 2 3 times, it will become 2 into 3. If you add 2 4 times, it becomes 2 into 4. If you add this term n times, so it will become this into n. So instead of this huge statement, what we can write? We can simply write 2Sn is equal to n into 2a plus n minus 1 d. Okay, now this 2 will go here. Sn is equal to n upon 2a plus n minus 1 into d, right? So this is the formula for n terms of an AP. N upon 2a plus n minus 1 d. So this is how. Okay, this is the only thing that you need to remember. If you get the derivation, you get it. If you don't get it, no worries. Just remember this formula that I have written at the end of this, derivation. So this is the important thing. So Sn, sum of n terms of an AP is this. So you can just put the values of a and d and n and you will get the sum of those n terms simply using this formula. Okay, now let's find out the Sn formula in a different way, right? Like relation between Sn and the last term and the first term, right? Okay, now let's find out the relationship between Sn and last term of an AP. So I'm saying last term. It means that only a finite AP will have its last term, right? So we are just talking about finite APs. So this formula that we are going to derive, that is only applicable for finite APs which has a last term, right? So let's say there is an AP in which the first term is A, the common difference is D, and there are only n terms in that AP, n terms. So how many terms the AP has? N terms. So the nth term would be an and an. An is nth term and nth term is given by a plus n minus 1d. So I said it has only n terms. So the nth term would be the last term for that AP. Okay, because it has finite number of terms, it has n terms, and the nth term would be the last term, right? So let's derive the formula. Just keep this in mind. Okay, this thing in mind, that L is equal to an, and an is a plus n minus 1 d. Okay, now split this formula, this Sn formula. So Sn is given by n upon 2a plus n minus 1 d. So instead of writing this 2a, what we can write? A plus a, can we write it? We can surely write it as a plus a, okay, plus n minus 1 d, n minus 1 d. Now just see, a plus n minus 1 d. So instead of, what is a plus n minus 1 d? Can you see? A plus n minus 1 d is nth term, and as it is a finite AP, so nth term is the last term. So instead of writing this much, what we can write? Simply replace it with L, last term. Okay, so we can write n upon 2 a plus L. Okay, so sum of n terms of a finite AP can also be obtained using this formula. Sn is n upon 2 a plus L, or what is L? L is the last term. Simple. So this is the relationship between the last term and the n terms of an AP. If you know the last term of an AP, no need to put this in this formula, just you simply write it n upon 2 a plus L, and you get the sum of an AP. Okay, cool. Now let's talk about one more formula the chapter has. Okay, now let's consider an AP, a general AP, right? A plus D, the first term, second term, right? So instead of writing a plus D, what I'll write it as A2. So this is the first term is A, so this is A2, then A3, and so on. Okay, so second last term would be A, instead of plus, because this is just an AP, a n minus 1. Okay, n minus 1th term, third term, n minus 1th term, and after n minus 1th term, what will come? Nth term will come. So this is a finite AP, right? So this is the last term, this is n minus 1th term, right? This is first term, second term, third term. Now if I say Sn minus 1, by Sn minus 1, what do you understand? Sum of n minus 1 terms of that AP. It means sum of these many terms. Sum of Sn minus 1 terms means sum of n minus 1 terms of that AP. Okay, so this is Sn minus 1. Now just you added all these terms, Sn minus 1, and this is Sn. Sn is sum of n terms of an AP, means we are adding all these terms, so including nth term, this term. Okay, so this is Sn, means the big circle, you are adding all those, and then Sn minus 1 is this. So what if I subtract Sn minus 1, the big circle minus this circle, what is left? Only an, nth term is left. So this is the formula. From here the formula comes, nth term of an AP will be equal to Sn minus 1. So this is a formula, simple formula. If you know the sum of n minus 1th term, you know the nth term, sum of nth term, n terms of that AP, you can simply find out the last term of that AP, that is an term, that is nth term of that AP. So this formula also you need to remember. Okay, so my dear students, by now we have discussed all the formulas. Okay, and I'll be pasting the snippet of all these formulas at the end of this video, so that you can access, don't forget to take the screenshot of these formulas so that you can access them whenever you want, right? So next video on, I'll decide how to go further, whether exercise wise or one formula and then question based on it. I'll see how I'll take it further, but you just cram these formulas up, and don't forget to like, share and subscribe to the channel. We'll see you in the next video. Bye bye and take care.